Assalamualaikum warahmatullahi wabarakatuh. My name is Nafiq Hamidi Tamin, and I will be the first presenter to present about the introduction for electric vehicle charger. So, the electric vehicles offer distribution firms a growing potential to capture new sources of demand flexibility while increasing income from a customer segment that is expected to increase dramatically over the coming decades. And since electric vehicles don't release air pollutants when they are running, they are less likely to cause noise pollution than traditional and combustion engines. So this can be realized by converting an ordinary household electronic device to an electric vehicle. And then the transformer was designed to be connected to a hash bridge which sends a high frequency voltage pulse to the primary coil, which is then converted into a higher voltage and delivered to a rectifier unit. And in addition to the traction battery specialist systems used for industrial or leisure vehicles, an electric vehicle battery is a battery intended to power the system of a battery electric vehicles. And typically, these are the secondary rechargeable batteries, where a battery that powers electric motors is known as an electric vehicle battery, sometimes known as a traction battery also. And instead of a buck type converter, an interleaf topology can be utilized to reduce the switching frequency and power rating of each semiconductor while keeping a low battery current ripple, taking into account the application and the nominal power of the converter, which is 50 kilowatt. So as a result, connecting batteries with various properties or edges in parallel might allow current to circulate between them, resulting in energy losses or even overheating of the batteries. And that is all for me. Then I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naziha binti Zainuddin. So I'm going to talk about methodology. So in our project, which is electric vehicle charger system, we use two types of converter, which is rectifier and also buck converter. So the rectifier is to convert AC voltage to the DC voltage, while the buck converter is to convert our DC voltage to DC voltage, where it will step down our DC voltage and will also we get the poor DC voltage. So our system, which is AC to DC converter for the electric vehicle charger, it will start from the single phase supply, which is 230 volt of AC. Then from supply, it will go to the rectifier to convert our AC volt to the DC voltage. Then it will go to the filter, which is we use capacitor as the filter. Then from this filter will it go to the buck converter, which is DC to DC converter to step down our DC voltage. Then it go back to the filter, which is we used the inductor and also the capacitor as our filter. Then after it filter the voltage, it will go to the load. Then for this project, we use MATLAB Simulink to develop our circuit. So this is our circuit in the MATLAB Simulink. So this is our single phase supply. Then this is our rectifier. This is our capacitor filter, and this is our buck converter, while this is our filter, which is inductor and also capacitor, and this is our load, which is battery. So the function of we use capacitor as the filter is we want to get the smoothing graph for the result, while the function of we use inductor and capacitor as our filter at the load side because we want to reduce our voltage ripple. So before we run this circuit in the MATLAB Simulink, we need to determine our capacitor and inductor value. Therefore, to determine the right value for the inductor and capacitor, we can use these two formula, which is we use this formula to find the right value for the inductor, while we use the formula to find the value for the capacitor. But before we use these two formula, we need to determine the duty cycle, which is V out over V in. Lastly, we need to determine what is our mode operation of DC to DC converter. Either it operates in CCM or DCM. Therefore, to know the mode operation of our DC to DC converter either in CCM or DCM, we can use these two formula, which is we need to find the maximum current and also the minimum current of our inductor.
Assalamualaikum, my name is Sharfan Afrina binti Syed Yusof and my metric number is DE190146. In this video, I will do the presentation about the design analysis and also the calculation. And I also will do the circuit simulation. So, for the design analysis, there are two stages of converter is proposed in order to convert the single phase AC supply to the DC voltage. So the first stage is the AC to DC converter, or also known as a rectifier over here. And at this stage, it will convert the AC signal, the AC supply signal, to a DC signal. The second stage is the DC to DC over here, DC to DC converter, or more specifically is a buck converter, which where it will step down the input voltage to a certain level or voltage needed by the load. So I will show the calculation to for all the parameter used in this circuit. This table is the parameter value that has been set. So as you can see here, our voltage source, AC voltage source is 230 volt. The ripple is set to be 5%. Our switching frequency is 20 kilohertz. For the AC to DC supply, the output voltage of AC to DC supply is 110 volt, and this is also considered as the input voltage of DC to DC converter. So we set our output voltage at the DC to DC converter to be 12 volt. So our input inductor L1 is our input inductor is 12.5 millihenry. Our resistor is set to be 1 ohm. Capacitor C1 and C2 is set to be 2.5 millifarad, and our resistive load is set to be 10 ohm. So this is all the parameter value that has been set. Now we are going to calculate the DC to DC converter. So first we can obtain the duty cycle from the equation 1 that my friend has previously explained. So to get the duty cycle is V out over V in. So our V out is at the DC converter, so 12, and the input voltage at the DC converter is 110. So V out over V in, we will get our duty cycle is 0.1 or 10%. Next, we can calculate the minimum value for the inductor. So to get the inductor value, this is the formula. So we will get the inductor value. The minimum inductor value that we can use for the circuit is 225 microhenry. After that, we can find the minimum capacitor value. So when we substitute all the value into the formula, we will get the minimum capacitor value is 12.5 microfarad. And then after that, we can calculate the minimum current and maximum current, the output current. So this is the formula we use to calculate the maximum current. So from the calculation, we will get the maximum current is 2.4 ampere, while for minimum current, it will be 0 ampere. We can see here, the system will be a DCM, discontinuous conduction mode, because our I minimum is 0. So when I minimum is 0, which means it touch 0, so it is a DCM mode. But we will see the simulation. Now I will show the simulation part. Here is our circuit. So over here is the AC voltage source. We set to be 230 and the frequency is 50 Hz. And then here is the LC filter. So previously I said that the resistance is 1 ohm and the inductance is set to be 12.5 millihenry for the inductor, and for the capacitor here is 2.5 millifarad. Okay. So this is the first stage converter, AC to DC. So we are using MOSFET. Over here is another filter, capacitor filter, which we set to be same value as this, 2.5 millifarad. And at this side, this is our DC to DC converter or buck converter. So this is the switch. We are using diode because it will allow only one direction of current. So our inductor here is set to be 225 microhenry, the minimum value for the inductor, and this is also the minimum value for the capacitor, which is 12.5 microfarad. and this is the resistive load, which is 10. To trigger the switches, the MOSFET, we need to give a pulse generator. So as I have said earlier, our switching frequency is 20 kilohertz and our duty cycles is 10%. Now I will run the simulation. Okay, so here I will show first the AC voltage and AC current waveform. This is the AC voltage waveform. This is the AC current waveform. This is the voltage waveform for the AC to DC output or DC to DC input. Next is this is the DC to DC output voltage. This is DC to DC output current. This is the FFT analysis for the input current. So if we see here the voltage at the load, it will be 10.05 volts. So for the calculation, we set the voltage to be 12 volt and the current is 1 ampere. That's all from me. Later my friend Auni will explain more about the output graph that has been obtained. Thank you.
Hello, good day, doctor. My name is Rishidharan Sivalingam. My matrix number is AE190040. I'm going to explain my part, which is conclusion. So, as a conclusion, the electric vehicle system requires conversion of supply, which are AC to DC power electronic single phase converter circuit. So, there are many various type of converter circuit, but we choose an AC to DC converter circuit, which require a harmonic AC input and converts it into a DC output. So these circuits are simply from a high level power and when operating at low level power, but a real AC to DC converter circuit is more complex that needs high frequency transformer. So thus the transformer was designed to be connected to the edge bridge, which sends a high frequency voltage pulse to the primary coil. So the harmonic distortion is simulated from the MATLAB, which is 0.17%, which is acceptable. So we have used the MATLAB software to analyze the power electronics converter based on the certain requirements. So the reason that we choose the MATLAB software is it is easy to program simulation circuit, and also it looks really tidy when it comes to bigger circuits and also simulations. So we have gained a good experience on performing a MATLAB simulation on the converters. So these basics will help us in our future upcoming projects. So that's all from me. Thank you.